Hello everyone, welcome to Unmanned Aerial Systems class. So this is a short video on how to approach your ROS assignment. So I will be going over some of the very basic ROS topics and ROS message structures and how to see them and how to run the TurtleSim nodes and how to generate your own ROS Python node and then run that. So I don't think I'll be able to put everything in one video, so it'll be 2 or 3 videos. I will also be going over this in the help session today and on Mondays, so feel free to be there. I would actually encourage everyone to be there. It would be really helpful. So let us begin. This screen, as you see, this is called a terminator. You can also do this in something called terminal. I am assuming that all of you have already installed Ubuntu and ROS, or you are using a virtual machine, or you are using any university-based computer where you already have your own workspace. So if someone doesn't have that, please feel free to mail me or let me know in the help session if you need any help regarding that. So this is called a terminator. I prefer terminator just because I can split up the screen in in 4 different windows. So it's Control-Shift-E for vertical splitting and Control-Shift-O for horizontal splitting. So the first thing that you would need to run in any ROS-based system is something called a ROS core, which is just the ROS master. I have a few things to change in this because I was running some other experiments, so just don't follow these steps. I will let you know which steps to follow. Yes, so now we will begin our ROS tutorial. So we always have to run the ROS master, which is called the ROS core. So just wait for it. It will actually show you what nodes are running and now starting new master. So right now ROS core is running, which means that your computer is going to run anything ROS related without giving any issue saying that it does not recognize the commands. So in ROS, we have something called messaging structures and topics. So message structure is basically the data type, and topics are actually the variables that you can access from different nodes. So if you consider a MATLAB, a Simulink block, so whatever comes in as your input to a node, that is called subscribing to a topic. And whatever goes outside a particular node, that is called publishing a topic. So you publish information and you subscribe to information. So right now I will show you, I will go and run a TurtleSim node, and then I will show you what commands we need to access the different TurtleSim topics and how you are going to be modifying that for your own code. Okay, so to run a TurtleSim, if you guys have followed the ROS tutorials, you already have TurtleSim installed in the beginners tutorials. So let's start from there after the installation. So it's ROS run TurtleSim node. So for auto completion, press tab. It is a good way to check that your nodes are executable and they actually exist in the path from where you want to run them. So I do this and then I press enter, and I have a turtle generated right here just beside. So I'll keep the screen like this so that it's helpful to see what the TurtleSim does. So now once I have a turtle on the screen, if you look here, it says spawning turtle 5. Okay, so this didn't come fully. I'll show you the location. So let us see what are the topics or what are the informations that I'm getting from this node. So what do? I write something called ROS topic list. I'm sorry, my computer sometimes lags. So yeah, so ROS out and ROS out AGG, as you can see, these get generated whenever you start a ROS core. These are not of importance to us right now. The two most important things that we will be dealing with in this assignment is the turtle1 pose and the turtle1 command velocity. The CMD vel means command velocity. So now turtle1 pose, it actually gives you the XY position and the heading of the turtlebot. So we can actually see what it is currently. So what do we do to print a particular message, particular topic's output on the screen? We do ROS topic echo, and then we write the name of the topic. So again, if the topic exists, you can write one or two alphabets and then do a tab, and it's going to autocomplete for you. It's a good way to check, so I would always suggest do that. Now if you look at this, you can see that it gives you X and Y positions. So at the center of this blue screen is the 5.54 location, and this entire grid is a 0 into 10 grid. And then theta, so theta is actually your heading, it is 0. So right now your heading is 0. Heading is always calculated from the x-axis, so just remember that. It might be needed for your assignment, and so it is 0 right now. And we also get linear velocity and angular velocity. So what is linear velocity? Linear velocity is the speed at which this turtle would be moving in a straight line, and angular velocity is the turn rate, or the turn rate, so how the turtle would be turning and translating. So now I can do a Control C. So now if you want to look at how do we send in data to this, supposing, right? So what we can do is that we can look at what is the message structure. So what is the topic type? So for that we do ROS topic type, turtle turtle1 pose ROS message show. So now if you look at this, all of them are float 32 variables, so float 32 types. So you can put in float 32 values for this. So this is how we can check the turtlebot's current position. So this gets updated when the turtlebot moves. Now the other thing that we are interested in, the other topic, the one that you are going to send in values to, that is called the turtle1 command velocity. So now command velocity, let us look at the structure of command velocity again. So you can just press the upper arrow and just go and change this. Sometimes saves time. So now if you look at the command velocity type, you see it's something called geometry messages, and then it's a vector of 3 elements, and one says linear and the other says geometry messages vector 3 angular, right? So this geometry messages linear and angular, this form is called the geometry messages twist. So I will show you how to import that in your Python file. But so this is the structure. Now what does the linear say? So this is actually your velocities. So linear velocities XYZ, and then angular velocities XYZ. So your angular velocities XYZ are your turn rates. So PQR. So if you're familiar with the quadrotor states or from modern controls, or if you're familiar with it, you know that. So P is the roll rate, Y is the pitch rate, and Z is the yaw rate. So yaw is the heading. So we are, since it's a 2D vehicle, we won't be having any roll pitch associated with it. So all that we are interested in sending our commands to, or all that we are interested in right now, is the float 64x in linear, which is the linear velocity, and the float 64z in angular, which is the heading rate. So how much must the vehicle turn, like what should be the turn rate of the vehicle so that it can move to a desired point. So right now if we do a ROS topic echo and try turtle1 command velocity. So when I press C and did a tab, it did not show me, because there are two topic types that can come, like command velocity and color sensor. So you have to give it a differentiating factor.